In our earlier videos, we were looking at decimal representations of rational numbers. While doing so, in the process, we found that decimals, in fact, p by q, the rational numbers in the form p by q, we tried converting them into decimals. And while doing so, we found that some decimals were terminating. Some of those decimals were terminating, and some others were not terminating. So I hope you understand what we mean by terminating and not terminating. If I have to give you examples, some decimals were in the form 0.825 and that is it, whereas some others were of the form 1.33333, which we also denoted by a bar on top of the repeating decimal. So this is non-terminating and at the same time repeating. Repeating can be called as recurring, right? So we saw decimals were of these two types. So whatever rational number we could think of fell under these two categories. Now we just had a question. So given any rational number, we could convert it into decimals. Given any decimals, our question was, at the end of the video, our question was, given any decimal which one could think of, could they be converted or can they be represented as a rational number or as a fraction? So this was our question at the end of the video, and let us try to see if there is any decimal which cannot be represented as a fraction. In fact, I had asked you to think about it. I hope even you would have thought about some decimal which you feel do not fall in these two categories, terminating and not terminating recurring decimals. Is there any decimal which do not fall under these two categories? Let's try this. Let me think of such a decimal. It's 2.4532789. It is not terminating, right? The decimal is not terminating. It goes on forever. At the same time, it is not even repeating or recurring. So until the end of this page, I can just keep going on, right? And even further, right? So these are not terminating, not recurring. So let me name it here. These decimals are non-terminating. In fact, it is not terminating, it's non-terminating, non-recurring decimals. Right? So, now I have thought of a decimal which does not fall under these two categories. So, obviously these decimals cannot be represented as a fraction, as a ratio of two integers also, because it does not fall under these two categories. Maybe if I decide to stop the decimal here, consider till 3 and represent it as a ratio of two integers. Like for example, if you have a decimal like this 0.85, how would you represent it in terms of two integers? By the definition of decimal as we go, like we have posted in our all about decimals video, by the definition of decimals you could just write the denominator as, count the number of decimal places 1, 2, so 2 zeros following a 1, 100, 85 by 100. This is how we represent a decimal as a fractional, as a rational number or as a fraction. So this non-terminating decimal could be stopped here for our convenience, of course, and we could count the number of decimal places, put as many zeros in the denominator as there are number of decimal places and the zeros following a 1, and write this number on top of in the numerator. Maybe this would be a rational number. It would be in the p by q form, but mind you, this is just an approximation. It will never be an accurate value because it does not consider all these decimal points, all these values towards the end. It doesn't consider. So it's an approximation. It can only be approximated to a rational number, but it can never be accurately represented as a fraction or as a rational number. So ultimately we have found some decimal which cannot be represented as a fraction. So the decimals can be further, we'll complete the decimal chart here. The decimals of the third type of decimals here is non-terminating, non-recurring or not repeating. Remember these decimals, the recurring decimals, we also had an example of 0.125, 125, 125. These are called repeating decimals, whereas here this one is not repeating. They do not, you cannot find a pattern which repeats itself. It's random values after the decimal place. So we have found, so our decimal chart is also complete. The decimals are of three types now. One is terminating, one is non-terminating. Let me change it here. It's not non-terminating. It's, yeah, of course, not terminating is not wrong, but this is the phrase which we use. Non-terminating recurring decimals, and the third type is non-terminating non-recurring decimals. Now, the third type of decimals which we saw just now cannot be written in the P by Q form, so it is not a rational number, right? And these numbers are called irrational numbers. The numbers which are not rational, the numbers which cannot be expressed as P by Q are called irrational numbers. Irrational numbers. These cannot be expressed in the P by Q form. So having said this, this is also a decimal. The number which we have given here, it's also a number. So it has to have a place in the number line, isn't it? So let's try to zero down that place in the number line. Now suppose this is your number line. It extends here. So look at the first decimal place. It's 4. It's 2.4. So the number, this particular decimal which we have thought of should lie between 2.3 and 2.5, right? It should lie somewhere here because it is 2.4. Now look at the second decimal place. It's 2.45. So it has to lie between 2.44. 2.44 would lie somewhere after 2.4. So it has to lie between 2.44 and 2.46. Now I can consider the third decimal place, and again I can narrow down the place where this particular decimal number can be pointed on the number line. But of course I do not want to bore you. I think you get a hang of it now, how to locate the decimal, this non-terminating, non-recurring decimal in the number line. Of course there is a place for this decimal in the number line, just like your other two decimals, the terminating and the non-terminating recurring ones. Just like those two decimals, this also has a place in the number line, and hence this also falls under the real number category. Irrational numbers are also real numbers. Real numbers are both rational numbers. Of course, under rational numbers comes your whole numbers, integers, natural numbers, everything, and irrational numbers, the standalone numbers, right? So I hope you have justified yourself, or you have satisfied yourself with the existence of such non-terminating, non-recurring decimals. So do such decimals exist? You may wonder. Do such decimals exist? Of course they exist. We can even locate them in the number line. If you're not satisfied with this explanation of existence of such kinds of numbers, just think of the square root of 2. Consider the square root of 2. We have seen it before also. What is the square root of 2? If you Google the decimal expansion of root 2, you will find that it is equal to 1.41421351. And it keeps going forever. It's not terminate. It does not terminate anywhere, and it's non-repeating also. Of course, calculators, if you feed in root 2 in the calculators, it will show you a definite value because due to lack of space, but actually they do not terminate. The square root of 2, the decimal value of it does not terminate and does not repeat also. So these are the irrational numbers. Now, not only root 2, even any other square root of non-perfect squares like root 5, root 7, root 10, all of them are irrational numbers. They fall under this category of decimals and they are irrational numbers. But the point of this video is getting introduced to irrational numbers by knowing that such numbers, non-terminating, non-recurring decimals exist. By knowing the existence of such numbers would give you more clarity than getting introduced to irrational numbers through these numbers, root 2, root 5, root 7, root 10, because this gives you an idea of where they would fall in the number line also, and it gives you more satisfaction that such numbers do exist in the real number system. So I hope you have understood and you have followed the purpose of this video also. Though you already knew that these numbers were irrationals, I was trying to tell you that a third type of decimals also exist, which are non-terminating and non-recurring, and these are irrational numbers. Thank you.